In this lecture, we will discuss continuous random variable. So we take continuous random variable. Basic example we have taken as that means height of a person, weight of a person is the part of the continuous random variable. But theoretically, how to define this continuous random variable? So we write down as a continuous random variable. A continuous random variable takes the range of values which may be infinite, finite, in extent. So the range may be finite range is 0 to 1. Second is 0 to infinity. Third is maybe minus infinity to infinity. Or general term we can write on finite range is AB. So we explain this as a random variable x. Now here we use the continuous random variable. A continuous random variable. A continuous random variable x. Or you can write down the definition. A random variable x is said to be continuous. This is better. A random variable x, we write down as a random variable x is said to be continuous. It's said to be continuous. Is said to be continuous if there is a function if there is a function fx such that for any closed interval cd we have the probability, we calculate the probability of a random variable x between c to d can be represented as integral c to d fx into dx. So fx into dx. So this fx is called probability density function. This fx is called probability density function, PDF. So in short, we denote it as PDF, probability density function. Now, the PDF always satisfy the properties. First property, the function fx should be greater than or equal to 0. So that means function f is non-negative. Function f is non-negative. That we take the positive function only. Second, the value of the function from minus infinity to plus infinity is equal to 1. That means the total probability is equal to 1. So we can say that this is equivalent to probability of minus infinity to plus infinity, that will equal to 1. So now we remember these uh, things. So that means when for continuous random variable, we use the integral instead of the summation. And when we evaluate this integral c to d fx into dx, the function fx is given. Now we can represent this as graphically. So graphical representation. For graphical representation, because function can be represented graphical easily. So if you draw the graph, of a PDF, probability density function of a continuous random variable. Continuous random variable x. So then we can write a probability of x lie between C to D is equal to, so this probability is equal to area under the graph, under the curve. We can write down the under the curve between C to D. So this curve or arc represented as, so that means we can say that this is our horizontal line, this is vertical line. So the function fx represented to the vertical line. Here we have origin. This is about x-axis. So we move this side as plus infinity. Here is negative axis. We move to the minus infinity. So suppose we have a normal curve, or we have a curve. So we have this type of curve. So we can take the ordinates C and D. That means here this is the C ordinate, this is the D ordinate. We are going to calculate the area between these two ordinates C and D. So this is our required area. So this is the required area, or we can say that this we can write down as random variable x lie between C to D. So how to evaluate this area? So we can using the integral. So you hope you understand the definite integral to evaluate the area. So we take the integral, that means from c to d, and the function is defined for this fx into dx for evaluating the area. So we can understand by using some example. So now we can take the example. Suppose x is a continuous random variable. We write down in short, has PDF. So the probability density function fx, fx is equal to 3. Fx equal to 3 in the interval 0 to 1 by 3. 0 to 1 by 3. Interval is given as, this is the finite interval. So what do you mean by this interval? So suppose we are drawing a line. When we are drawing a line, so that means the function is defined. The function is defined only for this interval, only for this interval. Otherwise, the function value will be 0. Okay, so basically this function is defined only for the given interval 0 to 1 by 3. So that means we can take the value fx equal to 3 only for this interval. Otherwise, when we take the interval as from 1 to infinity, so that function value should be 0. So we can say that. So the function, this means that the function fx is equal to 0 outside the interval outside the interval 0 to 1 by 3. So now we compute the value. So when we are going to compute the value of a point 1, random variable lie between point 1 to point 2. So we know that the random variable x which lie between point 1 to point 2. So that means when we are drawing this, so that means interval here is origin, so this is 0, and suppose we are considering 1 by 3 this side, so this is our x-axis. Here is the function x, so function fx is constant, that means that is equal to 3. So we have taken this interval, so in between them, that means point 1 by 3 means 0.33 approximately. So point 1 also lie here and point 2 also lie this side. So that means lie in between 0 to 1 by 3. So now when we evaluate the value of this, so when we are going to evaluate the value of this, so probability of point 1 to point 2 can be directly calculated as integral point 1 to point 2 fx into dx. So fx into dx, because the function which is defined from 0 to 1 by 3. So the function is defined from 0 to 1 by 3. So we can take as 0 to 1 by 3 fx into dx. So we know the CD. CD we write down as, which defined as from c to d fx dx. The function is defined for this, but we have some properties related to the definite integral or integral. So when we can write down 0 to 3 as 0 to point 1 fx dx plus point 1 to point 2 fx dx plus point 2 to 1 by 3 fx dx. So this is the outside range, because we are calculating only for point 1 to point 2. So we just take the value of this. So we, because our total integral lie inside, but we are going to evaluate for this only. So we do not evaluate this also. For particular this we are talking about the this interval point 1 to point 2. So here we take as integral point 1 to point 2, function is defined for the whole interval is 3. So this is defined as 3 into dx. So we can write down 3 into point 1 to point 2 into dx. So this equal to 3 integration of dx is x. So point 1 to point 2. So we can write down a 3 into zero point 0.2 minus zero point 0.1. So this is 0.3. This is 0.3. Now when we want to evaluate this by using the graph. So when we are going to evaluate this by using the graph, so function, this is constant. So here fx equal to 3. So y equal to 3. Y equal to fx. So we can take as here is 1, here is 2. So parallel to x-axis, 1 by 3 we have taken this. So this is a rectangle, but we are going to evaluate the area between this portion, means point 1 to point 2. So we are going to evaluate the area of this portion. So when we are going to evaluate this area of this portion, so this makes a rectangle. This makes a rectangle. So what is the area of a rectangle? The area of rectangle. Area of rectangle. So area of rectangle is equal to length into breadth. So length is equal to, we consider as, here is 3 and breadth is equal to zero point 0.1. So this is equal to 0.3. So the answer are same while evaluating by integral or solving by direct. Now next is let x be a random variable with range 0, 1, and PDF is defined as fx equal to cx square. So find c. So for calculating the c, so we already written the two conditions. One is for function greater than equal to 0, or second, which is probability equal to 1, minus infinity to infinity fx dx into equal to 1. So here we can write down as, we know that minus infinity to infinity, the probability is equal to 1. But a function is 0 to 1 defined finitely. So otherwise the function value will be 0. So we can write down this as minus infinity to 0. We break this function. So here is minus infinity, we have 0, we have 1, then we have infinity. So we break this function into these three forms. So minus infinity to 0, fx dx, plus 0 to 1, fx dx, plus 1 to infinity, fx dx, which is equal to 1. So the function is not defined for these two equal to 0. So we write down as 0 to 1, fx dx is equal to 1 when function is defined only 0 to 1 interval. So what is the value of fx? The value of fx is cx square. Cx square into dx equal to 1. C is the constant. So what is the integration of x square? Is x cube upon 3. So 0 to 1 is equal to 1. So we write down c. So when we put 1, 1 by 3 minus lower limit 0 upon 3 is equal to 1. So c into 1 by 3 is equal to 1. So C gives us 3. So the answer of C is equal to 3. Now, so when we obtain the expectation of continuous random variable, continuous random variable. For obtaining the expectation of continuous random variable, we take as expectation of x is equal to integral a to b x into fx dx. So where AB is the range of the integration and function PDF is defined as fx. Similarly, you are going to calculate expectation of x square. So this can be evaluated as x square into fx dx. So this is for continuous random variable. Other formulas remain same. That means when we are going to calculate variance and standard deviation. So remain same means variance is equal to expectation of x square minus expectation of x to the whole square, and standard deviation square root of the variance.